Okay, so using Pythagorean identities. The identities that we're going to be using are the tangent of theta equals sine theta over cosine. That is the same thing as the opposite over hypotenuse. Adjacent over hypotenuse, the hypotenuses cancel. The other identity is that the cosine squared theta plus sine squared theta equals 1. We have variations of this. We can solve this equation for the sine of theta, and that would give us plus or minus the square root of 1 minus cosine squared theta, sorry. Or you could solve it for cosine by subtracting sine squared over and taking the square root. So you would get those. These two are just variations of this one right here. Now, finding the approximate value of each trigonomic function. We're going to use the identities. We're given that sine theta is this. It's between 0 and pi over 2, which means it's in quadrant 1. Okay? So we know when we're in quadrant 1, the values are all positive. That helps us with that plus and minus at the beginning. But basically, we're going to use this formula. And we're going to say, all right, that means if I want cosine theta, because that's what they're asking me to find, it's plus minus the square root 1 minus the sine squared theta. So 1.0766 squared, because I'm taking it straight from there. When you simplify this and you take this, you plug it into your calculator. Please remember to square, then subtract it from 1, and take the square root. We get the square root of plus or minus, it ends up being 0.643. Now, because of this part right here tells us we're in quadrant 1, that means in quadrant 1 all our values are positive, so our answer is actually just 0.643, the positive value. So we're going to try that again. We're going to do it with given cosine and sine, except for they're going to change which quadrant we're talking about. So here, we're given cosine is negative 0.906, but because it says we're between pi and 3 pi over 2, really quickly, looking at this, 90 degrees is here. This is pi over 2. This is 0. This here is pi, this is 3 pi over 2, and this is 2 pi. So it's telling me I'm between pi and 3 pi. So I'm quadrant 3. And in quadrant 3, the x values are negative, and the y values are negative. So that kind of helps us with our little plus and minus. Okay? So looking at this, we're going to use our formula that says, all right, that means that the sine of theta is equal to plus or minus the square root of 1 minus cosine squared theta. We're using a variation of the identity. We're going to plug in that value for cosine. Be very careful because you're going to end up with that double negative if you don't pay attention. You cannot change that double negative to a positive until after you square your value. So this actually becomes 1 minus that number. And off the top of my head, I don't know what it is, and my calculator is way over there. But I do know that when you subtract it from 1 and you take that square root, you get 0.423. Okay? We're in quadrant 3, both values have to be negative, so that means we don't want the positive part of it, we want the negative. We have to pay attention to the signs depending on the quadrant that we're in. Alright, we're going to try another one. These notes today will be short in comparison to the ones you took before. Given that tangent is negative 2.327, we're between pi over 2 and pi, so that means we're in here, quadrant 2. X values are negative. The y values, though, are positive. Okay? We want to find sine and the cosine. So we're going to start by trying to find one of them. I know that if I take the fact that the tangent of theta is equal to the sine of theta divided by the cosine of theta, I can solve that for sine by multiplying both sides by the cosine. So that gives me that the cosine of theta times the tangent of theta would equal the sine of theta, because those would cancel. Okay? We know that the tangent of theta is equal to this value. So we're going to substitute that in. That gives me the cosine of theta times negative 2.327 is equal to the sine of theta. Now, using my Pythagorean theorem 1, the cosine squared theta plus sine squared theta equals 1, I'm going to do some substitutions. So sine squared theta plus cosine squared theta equals 1. Well, I'm going to replace this right here, this sine squared theta, with this mess, and I have to square it. So here's what we get. We have the cosine times negative 2.327. This whole thing has to be squared, plus cosine squared theta equals 1. Okay? Now, we have to square both of these. Whoops, there's a theta in there. So this is, when I square this number, it's going to become positive, and it is 5.414. And we have cosine squared theta plus cosine squared theta equals 1. I'm going to factor out. They have a common factor of cosine squared theta. So I'm going to take out my cosine squared theta. That leaves me with 5.414 plus 1 equals 1. So when I add that together, I get 6.414 equals 1. I'm going to solve for the cosine squared theta by dividing out that 6.414 on both sides. So that gives me 1 over 6.414. Now, to get cosine of theta, we actually have to square root it. So here I get the cosine squared theta. This ends up being equal to 0.156, and then you square root both sides. So I get the cosine of theta is equal to plus or minus 0.395. Now, the cosine, because we're in quadrant 2, cosine is the adjacent, which is your x value, okay? And the x value is going to be negative. So we want the negative version of this. Now, to find sine, way over here, where did we go? We said that sine was equal to whatever the cosine was times the tangent. So I'm going to say sine of theta is equal to the cosine of theta times that negative 2.327. I'm going to plug this number in for the cosine. So sine of theta is equal to negative 0.395 times negative 2.327. Negative times a negative is a positive. And my answer is 0.919 for the sine of theta. So I have my sine of theta here, I have my cosine of theta here, and I am done, and I've used my identities. Please make sure you get all examples written.